So another question from JEE Mains 2018 exam, question number 84, okay, where they have given you 3 complexes and they have asked what will be the oxidation state of chromium in each case, okay, oxidation state of chromium. So again, if you know the oxidation state of say ligands, you can easily calculate this, okay. So let us go for the first question where we have CrH2O6, okay, and Cl3, okay. So for this case, let's assume that because we don't know the oxidation state of chromium, so let's assume that it has got oxidation state of +6, okay, sorry, X, okay. So let's say this is X because this is the unknown quantity that we need to find out, okay. And then for H2O we know that it contributes 0, right? So we have 0 multiplied by 6, so all the 6 H2O ligands here will contribute 0, and then another is Cl, okay, and Cl is what, -1, so we will have 3 multiplied by -1, and because this is a neutral ligand there is no charge, so it should equate to 0, and if you calculate it, what we will get is X is equal to +3. So oxidation state in this first case will be +3. Now let's go to the second complex that we have. The second complex is chromium C6H6 twice, okay. So here it is very simple because we know that for this, let's say X is there, okay, and we know that for C6H6, so it chromium is coordinated through the pi electron density, and this ligand contributes actually 0, nothing, right? So will be 0, and again it is a neutral ligand, so it should equate to 0, so X is equal to 0 in this case. So if you want to show the ring, what you can do is, so this is the kind of complex that it is going to get formed, okay. So this is your ring density and chromium is somewhere here and it is attached to this electron cloud, okay. And in the similar fashion on the opposite side as well, you need to do this, okay. So again here we have 0, so the answer for this is 0. Pardon me, I should not write plus or minus here, so it will be 0. And then next the complex is a little bit tricky, so we have K2 CN twice and then O2 and then NH3, okay. So if you calculate here, so this is a bit long, so potassium is always +1, so let's say 2 into +1, okay. For chromium it is X that we have assumed. For cyanide we know that it is -1, so 2 multiplied by -1, okay. And what about these two? So what you need to do is you need to look at the structure. So if chromium is there, okay, so let's say that this whole complex has K2, okay, and this chromium is attached to 2 oxygens, so let's say this is one oxygen, this is another oxygen, okay, and then we have 2 cyanide. So this is a rough diagram, okay, we have 2 cyanide and then we have O2, so that means upper oxy linkage, okay. So if you look at this diagram, what will happen? So I should draw a double bond here, okay. So if you look here, this will contribute -1, okay, this will contribute -2, and this together contributes -2, that means -1 from this side and -1 from this side, right? So if you remove, this is forming 1 bond, this is forming 2 bond, this is forming 1 bond, so by this you can easily calculate this. So we have written for cyanide and then we have this, so this will be 2 into -2, and then for this we will have 2 into -1, okay, and for ammonia it is 0, so there is ammonia as well, okay, so you need to draw the ammonia as well. So we have one NH3 here which is nothing but 0, okay, because it is simply the lone pair donation, you can say something like this, okay. So this we need to equate to 0. So if you calculate this, what we have is +2 plus x -2 -4 minus 2 is equal to 0. So we can simply say that x will be equal to plus 6 in this case. So the answer here will be plus 6. So this was the option number 1 where they have written plus 3, 0 and plus 6. So this will be the correct option for this case.
Explore more about the topics you love with Toppr. Subscribe now and keep learning.